Hey guys, what's going on? Blazinblevins here. Today we're going to talk about Scavengers, but instead of talking about the game itself, we're going to take a look at the technology behind the game called Spacial OS. I believe understanding what Spacial OS is will give us some insight into how big this game could possibly be. Now I'm going to show you two videos. The first video is going to be from the Game Developer Conference in 2017, where the co-founder explains how Spacial OS works versus the way the games are made today. And then the second video is going to be a live tech demo from 2018's Game Developer Conference, which just happened like a month ago, showcasing Spacial OS live working in a game. I hope you guys enjoyed this video. If you do, please remember to give me a thumbs up. I'll be back to talk a little bit more after these videos.
And that's kind of the model that we're working with as well. So a little bit of an understanding of exactly what the architecture looks like. So currently, you would have a single game engine monitoring an entire world, running on a server with clients connecting directly to it. In a sharded game, you'd have several of these, and clients would jump between them. In an arena-based game, you'd have basically many of these spinning up as needed to cope with arena sessions. And the big limitation with the current approach is really twofold. One is in the difficulty of building and working this way. You have to explicitly write code that synchronizes information between those clients and that server. And the second problem is the limitations of this model. Because if you do more compute than that single server, engine, or worker can handle, you're just kind of out of luck. You have to minimize what your game can do. And even though you may have more compute power available, there's no easy way to take advantage of that. And actually building systems at scale is really a whole other headache on top of that. The approach with Spatial is really different. You build a single logical world where you write behavior as though you were writing on just one server. And behind the scenes, what Spacial OS is able to do is basically partition the world dynamically. So every moment in time, we're repartitioning the world, moving work between machines, and reassigning engines and what we would call workers, which Rob will talk about, to different parts of the problem. So as you code the game, you just think about one world with things in it, with entities in it, and with behavior being done in game engines or special processes that you can write if you want to. And what Spacial OS does is totally reallocates everything. So I'll give you an example. Let's take this room. If everyone in this room has flooded in from the Moscone Center, many different workers would be automatically spun up to cope with the physics of this room, to cope with the AI of all of us. I mean, we need a lot of compute power for the intelligence in this room. And on top of that, we would need to keep everything persistent and synchronize all of this information with all of the clients that might connect to the world. So this configuration may need like 20 cores, let's say, to make it work for this room. That would spin up to make that happen. And the people that coded this game wouldn't have needed to think about that at all, only the behavior they wanted to model. If everyone then dispersed, some of those workers could go down or be reassigned to other parts of the world. And maybe the game requires less compute power to make it work. And this dynamism and separating, building the logic of a world from managing the infrastructure creates enormous efficiencies. It means that these experiences can be cheaper, but also that we can build far more complex worlds more easily. All of the state of your game is synchronized and managed outside of a game engine. So basically, Spacial OS is also a big persistent database that manages all of the content in your world and makes it really easy to add in new components or to cope with failure. And it also vastly simplifies how you think about architecting a game. Even for an arena game with sessions, as we're going to talk about in the future, adding in additional things, Spatial becomes quite powerful because it's quicker to build this way, and an individual session could be bigger and more powerful than what a single server could do. But at the moment, our focus is really on online worlds with a degree of persistence. The other key thing is because all the information is stored in Spatial and managed outside of an individual game engine, you don't need to worry about plugging in different types of clients. If a mobile phone needs information synchronized differently, and a VR client needs higher update fidelities, all of that is managed by Spatial, and you can specify those properties. One of the key differences here is there's no game loop. The whole thing is a big simulation running on many different processes, and it's much easier to manage and think about.
A demo game developed in Unreal Engine 4 by Improbable to show what Spacial OS brings to a multiplayer online game. Spacial OS empowers you to realize your most ambitious game design ideas. In this guided playthrough, you'll explore how Spacial OS can enable things like massive scale, meaningful persistence, rich systems, and emergence. Welcome to our game world, Gliese 667cc, built using the Unreal Engine. This planet is rich in vegetation, But there's a lot more here than trees. By leveraging distributed computing in the cloud, Spacial OS allows the game world to be truly huge, 400 square kilometers in fact. It also lets up to 1,000 concurrent players connect and play simultaneously. You can see them landing in pods all across the world in real time. All players exist within a single persistent game shard or instance. Spacial OS enables this by removing computational barriers to massive worlds and massive player numbers. The world is not just huge, it's also a living, persistent ecology maintained by Spacial OS. This ecology is based around energy. It's the resource that fuels all life in the simulation. It motivates the actions of both player characters and AI-controlled androids. There are thousands of individual AI drones in the game world. These bee-like creatures are the bottom of the food chain, harvesting energy from trees, fungi, or other fallen creatures. Energy is a finite resource in the world that can change hands as creatures migrate. This means that areas can become emergently more useful to capture or defend. Alternatively, they can become more barren and unprofitable to keep hold of. More aggressive drones can form into packs, roaming the world seeking out energy and attacking other creatures to steal it. Players also require energy to survive, creating a gameplay motivation to compete with AIs in PvE combat. In such a huge world with a finite resource to fight for, it's important to collaborate. Pre-built character classes work alongside emergent player behaviors to allow players to find their niche in the game. When lots of people get together in virtual worlds, massive PvP battles frequently occur. These intense firefights are made possible by Spacial OS running multiple instances of Unreal Engine simultaneously. The players here are not actually fighting for energy, they are fighting for control of a relic that, when captured, can trigger the mothership's superweapon to attack rival factions. Success! The relic has been secured. Now to deploy the mothership's superweapon. The weapon is controlled by a live map that shows which areas of the world are owned by each faction. Of course, since this is a truly persistent world, there are no resets or world wipes. Territory gained is held until another faction takes it back. Actions have consequences in a game built on Spacial OS, and this rival faction is about to feel the brunt of them. The mothership unleashes its attack. Before we take a closer look at the impact site, let's view more of the world. This simulation has over 100,000 individual trees and rocks, coexisting with 10,000 AIs and 1,000 players. This level of complexity creates the sense of a truly living world through unpredictability. As Spacial OS handles the weight of all this computation, there's less stress on the player client and no trade-offs in terms of graphics. Here we are at the target site, just in time to see how the mothership is changing this part of the world. Things in this area could get very dangerous indeed. The mothership has deployed a hunter, a deadly apex predator that can drain an area of all its energy. It's a gamble for the player. If anything is to be gained from this part of the world, the hunter must be stopped. The player has prevailed, but now must compete against AI wildlife to raid the hunter for resources. Of course, this is just one player journey in an enormous, persistent Spacial OS-powered game world. The game's ecology and rich simulations set up the perfect conditions for emergent experiences, which are just part of the power of developing a game with the Spacial OS platform. We hope you enjoyed this playthrough of Survival and have a feeling for some of the unique game design features made possible by Spacial OS. For more information on how Spacial OS achieves these and how it can make your impossible game possible, talk to our booth team now. Thanks for watching.